Hi, and welcome to the GX video series and podcast. We're at the World Government Summit 2023, and I have with me in this episode Jamie Metzl, a well-renowned futurist, and he works across many different areas, healthcare. You're part of Atlantic Council, and incredible things are in your way, my friend. Tell us more about yourself and tell our viewers and listeners who you are.
So, well, as you said, my name is straight, and if I get that wrong, my mother will be very upset with me. Jamie Metzl, you're right. I can't decide what I am, so I try to be as much of everything as
Yeah.
possible. But it aligns with the world that we're in now, where we're seeing a super convergence of all these different technological and social and cultural revolutions. And so, for all of us, we need to focus on the small things and see the big picture as well. So, in terms of background, for my present, I'm the founder and chair of a global social movement called OneShared.World. As you mentioned, I'm a senior fellow of the Atlantic Council. I'm the author of 5 books. The most recent is Hacking Darwin, Genetic Engineering and the Future of Humanity. I have a biotech investment fund called the Wisdom Tree Biorevolution ETF. I just finished serving on the World Health Organization Expert Advisory Committee on human genome editing.
Excellent.
Yeah.
Tell us about Hacking Darwin. What's the book about, and what are you trying to?
Yeah. So Hacking Darwin, the subtitle is Genetic Engineering and the Future of Humanity. And so the basic story is that we humans have evolved for about 3.8 billion years by the set of principles that we know as Darwinian evolution, random mutation, and natural selection. And now, really for the first time in history, for the first time in history, our one species among the billions of species that have ever lived suddenly has the increasing ability to read, write, and hack the code of life.
Yeah.
And that's all of life, but it also includes our life. And so what we're going to see over the coming decades and certainly centuries is humans will stay a sexually reproducing species, but we won't reproduce through the physical act of sex, or we won't do it nearly as much. And the reason is that doing so will make it possible to apply science to the process of reproduction. And that scares people, but we need to recognize that that biology is buggy by design. When we talk about random mutation in evolution, it means that every next generation of every species is a little bit different from the past generations. And in humans, sometimes you'll have a kid that has perfect pitch and it's great, and sometimes people have kids that have deadly genetic disorders. And so that's why we have healthcare, to reduce the risks of those things. And we will want to reduce risks and increase the possibility of whatever we consider desirable outcomes across the board, and that will also be applied to human reproduction.
Right. So and you've written a book on this, and you're literally the authority on it. Genetic engineering over the last, I would say, decade or two has, it often comes, most of the time, comes under criticism, right? Is this right? Is this wrong? Where are we going? Where are we headed? Let's talk about the future of the human civilization, human species. 100 years ago, or even 50 years ago, before that, there was no access to genetic engineering.
Right.
We could do nothing about it, right?
Kind of and kind of not. Yes, we didn't know anything about CRISPR. We didn't have tools of molecular genome editing. But we did have, and our ancestors had, just our brains and our logic. And over the course of 10 plus thousand years, knowing nothing about genetics, our ancestors completely transformed the entire world. We created plant and animal agriculture. We just changed everything, and those changes were on a genetic level. Then we had new ways of altering genetics after, certainly in the nuclear age, of bombarding seeds, for example, with radiation. We even tried it just for our own cells as part of nuclear medicine. And what's happening now is we are just getting better, faster, stronger tools, and we're applying them across the board. And that's my next book, is the future of life. But Hacking Darwin is how we are applying that to humans, both in our healthcare and increasingly in reproduction.
Of course. So is it possible for us to get rid of disease in general?
Not possible at all, because disease is a moving target. Our ancestors, they died of all kinds of diseases, lots of infectious diseases. And then we've had healthcare, and we've changed the mix of what people get sick from and what people die of. But as I said, humans are buggy. Biology is buggy. if we live longer, we'll just be exposed to more things. So we're not going to get rid of disease, but we're going to increasingly get better at managing disease. Some diseases we'll be able to prevent, some diseases we'll be able to cure. And the goal is just, I don't think we will never get rid of disease, but we'll be able to live healthier, longer, and better.
Yeah. What about longevity? Longevity is a conversation in many parts of the world across different groups of people. Uh, there's the school of thought that talks about the microbiome, the gut microbiome. There's others who talk about NMN and ribo, that whole science of activating your younger genes. How, is that, like, which ones are legitimately on the breakthrough of
So
changing?
I have a chapter on this in Hacking Darwin. I'm very involved in that world. So a few things on longevity. Human average health span has increased very significantly. At the time of 2,000 years ago, it was around 25 average. Only about a little more than 100, about 120 years ago in the United States, it was around 40 average. And now it's certainly in developed countries, it's getting to be around 80. And that's all very positive. And the reason for those increases have largely been things like public health, worker safety, nutrition, all these kinds of things that everybody knows that they should do. So when we talk about extending human health and lifespan, the first thing that I always say is we have some easy wins because we know what it takes so that everyone can live kind of like the longest lived people in Japan or in these blue zones. And we know that if we just look around the world, there are people in other parts of the world, parts of Africa, South Asia, who are living much shorter lives, including in our own. I live in New York City. You just get on the subway and literally in a 10-minute subway ride, the average lifespan drops 20 years of the people in those communities. So the first and most important thing that we should do is just to say, how do we extend the benefits that have allowed some of us, more just advantaged people wherever we are, to live these longer lives? How do we get that to everybody? That's the most important thing. The second thing is, for all of us, how can we extend our health span? So the part of our lives where we live healthier, and the basic summary is everybody should do what they do in blue zones. Lifestyle, diet, exercise, all those kinds of things, that's so much more significant than any of these scientific applications. You talked about the NAD plus boosters or metformin or parabiosis and blood serum and all those kinds of things. Exercising an hour a day and eating a healthy diet and sleeping and having a loving community and all those things are much more important. Having said that, we humans are greedy, and we're greedy for ourselves, we're greedy for our parents, the people we love, and we want them to live healthier longer. And so the question is, are there, in addition to doing all these things that we should be doing, are there things that we could get, like if I could get an extra 5 years of health span to have my parents around just to see the legacy that they've built, I would love it. I think everybody would. And that's the new science of longevity. And it turns out there are lots of different ways to hack biology. And so there's a lot of research on basically our cells are constantly, cells don't make decisions, but they're in a kind of molecular level, they're trying to figure out how to allocate energy and whether it's towards growth or essentially toward repair. And when you're young and growing, your cells just want to grow. They want to scoop up energy. But when you're older, you kind of want your cells to go on screensaver mode. So they're doing what they need to do, but they're not. And so that's why some of these, the type 2 or diabetes drugs like metformin, they're just essentially getting human biology to function a little bit like these Icelandic clams that live for 500 years in these freezing temperatures because they've gone into screensaver mode. I mentioned parabiosis, which, don't try this at home, ladies and gentlemen, but if you cut open an old and a young mouse and keep them alive and you sew them together, eventually, doesn't even take that long, the old mouse starts to kind of become young, like its fur gets better, its bones get stronger, its eyes get better, and the old mouse kind of becomes old, even though they're tied together, it kind of averages out. And there's essentially information that's being transferred in the blood serum from young to old and vice versa. And so there's a whole new field of people thinking, well, how can we use that insight and translate that? So there are a lot of these things. People say some crazy stuff, and certainly there's the whole transhumanist movement where people say we're going to live forever and whatever. We're not going to live forever, but if we can live healthy a little bit longer, and if we can spread the benefit of things that we already know to disadvantaged people, so that they can live lives just like we're living now, which would be really great. I think that's great. And then final point on the science of healthcare, the science of aging. In pursuing the science of aging, we're developing uncovering a lot of insights that apply to the diseases associated with aging. So cancer, heart disease, dementia, they're all associated with aging. And so exploring the scientific and biological underpinnings of aging, I think, is a really important way to be able to better treat those diseases.
Amazing. It's been a pleasure speaking with you here at the World Government Summit, and we wish you an amazing next book writing. Tell our viewers and listeners where they can find you. And
So you can find me on easiest way is on my website, jamiemetzl.com, JAMIEMETZL.com, and at Twitter at Jamie Metzl.
Amazing. Jamie, thank you so much, my friend. Take care.
Thank you.
And that's the end of this episode. Please watch our next episode and others in the series. Thank you.